Hello everyone, I'm going to do an experiment today showing chemical reactions. I wanted you to see that I have my closed-toed shoes on, I have my gloves on, and of course I have goggles on my face. So I want to get down so you can see my face. And I just don't know that you won't be seeing that while I'm working. But before we do any experiment involving chemicals, we must be prepared. You can see from your lab, the first thing we have is water, some ammonia, which is the primary ingredient in Windex and other household cleaners. So you may have used ammonia in your household, or you may have some underneath your kitchen sink. The next one is copper sulfate. Probably don't have this, and this is why you're probably not doing this lab at home. Copper sulfate is a chemical that I would get from the chemical store, and I've mixed up a solution of copper sulfate and water. Let's make observations before we start. Water appears to be a clear, colorless, odorless liquid. I know it's odorless because if I come to take a sniff, of course I'm not going to breathe in directly, I'm going to use a wafting motion, and I smell no odor. So water looks like a colorless, odorless liquid. Copper sulfate. I would say that's a very light blue, kind of a pretty blue. And if I take a waft, it too is odorless. I smell nothing. Ammonia is colorless. And let's see, whew, yikes. It is definitely not odorless. It is really stinky. It smells conspicuously like someone has peed in the room. Our first direction is to pour 10 milliliters of water from the beaker. This is a beaker. You know it's a beaker because it has a beak and it's open on top. I'm going to pour 10 milliliters into my graduated cylinder. I know it's probably hard for you to read on the screen, but there are markings on here which tells me how much volume I have. So I'm going to go ahead and measure my 10 milliliters of water in a graduated cylinder. I'm going to get down to the level of my graduated cylinder and pour in 10 milliliters of water. I look at the meniscus formed inside the graduated cylinder because the bottom of my meniscus is what I want to read. I never want to read the sides of the graduated cylinder. I want to read the center meniscus. And that's my 10 milliliters of water. Now I need to measure 10 milliliters of copper sulfate. Again, getting down to the level of the graduated cylinder. And you can see that the copper sulfate has a light blue color. Now we're going to take our 10 milliliters of water and pour it into the Erlenmeyer flask. This is an Erlenmeyer flask. In goes the 10 milliliters of water. Let's look and see if any kind of chemical reaction occurs. Well, it's still light blue. I don't smell any odor. I don't see anything forming inside the flask. Those would be my observations. Time for the ammonia. 10 milliliters of copper sulfate. I'll use a new flask. And first, pour the clear liquid, the ammonia. And now I'm going to pour in the copper sulfate. Whoa. You could see here and here, we have some different colors going on. If I give it a swirl, we've gone from a light blue liquid to a very dark blue liquid. I'm going to try and get you to see. Inside here, I know it's hard to see on the video, but there's little specks of white floating around in my liquid. These are our end products. We can see the one with water and copper sulfate remains a light blue color. The one with ammonia and copper sulfate has a very dark blue color with white specks floating in it. So when you go to write your conclusion, please make sure that you state your reasons for why you think water and copper sulfate, ammonia and copper sulfate. Two different substances combined with the same substance. Remember your EDD chart. Which one shows a chemical reaction? Make sure you explain your hypothesis.